Did you know that every chemical reaction in the universe depends on how tiny particles called electrons are arranged inside the atoms? From the oxygen we breathe to the metals used in the technology, the behavior of elements depends on their electron arrangement. Today, I will explain the electron configuration, which describes how the electrons are organized in the orbitals around the nucleus of an atom and why understanding this organization helps to the scientists to predict the chemical behavior. Electrons don't move randomly around the atom. They occupy a specific regions called orbitals, which are organized by the energy levels. As shown in the diagram, electron fills orbitals following the three fundamental principles. The first is the alpha principle, which states that the electrons fill the lowest energy level orbital first. For example, the electron fill the 1s orbital before the 2s orbital and then the 2p orbital. The second is the Pauli exclusion principle, which tells us that each orbital can contain a maximum of 2 electrons, and then those of the electron must have the opposite speed. And the third principle is the Hund's rule, which explains that electrons fill the empty orbital individually before pairing up. This helps to reduce the repulsion between the electrons. Let's look at an example shown here with the neon, which has 10 electrons. Following the rules of electron configuration, two of these electrons fill the 1s orbital, 2 electrons fill to the 2s orbital, and the remaining of the 6 electrons fill the 2p orbitals. So the electron configuration of neon is 1s2, 2s2, 2p6. This arrangement makes neon very stable, which is why is that a noble gas and rarely reacts with the other elements. The periodic table is actually organized based on electron configuration. The blocks of the periodic table represent the different types of orbitals: s orbital, p orbital, d orbital, and f orbital. This means that the position of element in the periodic table reflects how its electrons are arranged. In summary, the electron configuration describes how the electron fills orbital using the alpha principle, the Pauli exclusion, and the principal Hund's rule. Understanding the electron configuration allows the chemists to predict the structure, the stability, the reactivity of the elements. So, for the next time you see a chemical reaction, remember that everything begins with the invisible organization of the electron inside the atoms. That's my presentation.